Well, hi. Hey, guys. This webinar's for Mita. She's been pestering me non-stop to get this webinar done, so I'm going to try my best to do this in one sitting. It's going to be pretty quick, so try to keep up. So this is the edexcel iGCSE Chemistry January 2016 paper. I'm just loading up my YouTube channel and through the chat box up. I highly doubt that I'll have any. So this is the edit. There we go. I highly doubt that I'll have any viewers, but that's okay. It'll be a resource for me to keep. So there we go. That all seems to be working just fine at the minute, which is great. Okay, so I'll share my screen. I'll also flip my camera to my clip cam. There we go. Fella. All right. Let's go share screen. I'm just going to grab my fan. Just keep my laptop a little bit cooler. And there's Mita. Yes, I'm first on the chat. Okie, you do have viewers. That's really sweet. It's nice to see you all. Mita, what time is it where you are? It's been like 3 in the morning or something. That's crazy. Right. Okay, so I'll start from the top. I'm going to see if I can do, this is a 2-hour paper. It may be split into 2 halves, Mita. I'll do my very best to get the next one done either today or tomorrow. So this is just the paper 1, so it's the lower level paper. Zaina, who is here, it's nice to see you, Zaina. Thanks for coming along. So Zaina is in year 10, finally for the first time. Zaina's in my year 10 class. I've done quite a lot of GCSE Chem with her already, so it'll be interesting to see how much of this she's going to be able to contribute towards. It'd be lovely to have some questions on the chat, guys. If you can contribute, that would be amazing. But otherwise, I'll try and be as brisk as possible. So, question number 1 about elements hydrogen and oxygen. Circle a diagram that represents molecules of hydrogen. Place a cross in the box of the diagram that represents hydrogen gas. Well, none of them do because it's complete garbage, but let's just stick with that. It's rather irritating. Yeah, we know that hydrogen goes around diatomically, and those are not diatomics, but I'll forgive them in this particular instance. Yeah, the diagram below shows 2 different atoms of hydrogen. Okay, so they're isotopes of each other. The particle furthest from the center of each atom, so that's this guy, is going to be an electron. The particle's present in atom Y, but not in atom X. That's this guy here. That's a neutron. So hydrogen is element 1,1. And from an atomic perspective, it usually has 1 proton and 1 electron only. So it's an unusual thing. See, this is called deuterium, by the way. Deuterium. Heavy hydrogen has an extra neutron. Both atoms are neutral because they have the same number of protons and electrons. Nice and easy start. I like it. Okay, so now we're looking at 2 isotopes of oxygen. Yeah, so you may use the words once, not at all, multiple times. It's almost 8:30. 8:30 in the morning. Where are you, Mita? Where are you? These atoms of oxygen are called isotopes. Because something are the same, their atomic numbers are the same. So that's that one, the atomic number. The atomic numbers are the same, but their mass numbers, which is the top number, mass numbers, there we go, are different. So that's just quite nice. We got the atomic number here, atomic number, and then we've got our mass number there, RAM. Actually, no, sorry, it's actually mass number. It's actually mass number, not RAM. Yeah. Yeah, atomic number, mass number. Anyway, moving on. Next. Okay, methods of separation. Hey, Harry, how's it going, dude? I hope, Harry, you've had a chance to re-watch my chemical test video. It was a bit quick. It was still 1 hour and 20 minutes long. Sorry it was so long. I just had a lot to cover. And I hope you've been doing the paper 3s. So to separate red ink from a mixture of colored inks is chromatography. To separate ethanol from a mixture of ethanol and water, that's fractional distillation because they have similar boiling points. Yeah, water has a boiling point of 100. Ethanol has a boiling point of 78. Next, sand from a mixture of sand and water. That's going to be, oh, we want the sand, filtration. And then the last one is water from copper sulfate solution. We can do simple distillation for that one because we want the water in the copper sulfate. This is the 2015 paper. I guess you messed up. Oh, this is the 2015 paper. Oh, darn it. Oh, that's irritating. Do you want me to start again, Meter? Would you like me to do... Yeah, I did rewatch the videos. Do you want me to do the 2016 paper? I can switch. It won't take me very long to sort it. I think I don't want to do one that I've already done before. Happy to switch it to one I've not before. There you go. By the way, I hope you know, Meter, that PMT has all of these on it. iGCSE Chemistry. International edexcel, paper 1. Don't know how that's going to happen. 2016 Jan. Look, then it's given me 2015. That's why there's been a mistake on the website. How fascinating. So at that point, that might become tricky. They may have reversed them, I guess. No, they've just posted it twice. Oh dear. Oh, that's irritating. And I bet this one is 2017. How fascinating. Yeah, that's right. They're missing 2016. So let's Google it. Ah, that's... Sorry, I should have probably read the date. This might end things at this point, Meter. Because now I'm going to have to track down where to find it. I can never remember where to find these. Past papers? Yeah, never used that before. Chemistry. iGCSE Chemistry. Jan 2016, question paper 1. Hey, download. There you go, Meter. Sorted. So that's wrong. So, Jan 2016. There you go. At least I've got it now. Let's try this again. Well, that's a disaster, isn't it? I don't know if I can edit these. Insert. Print out. Let's give that another go. Let's hopefully this is the right one, Meter. Can you let me know whether or not this one's the correct one? My laptop's working away. Right, up to the top. Ooh, come on, laptop, quick as you can, please. It's a long paper. Is this the one that you now want, Meter? Let me know, quick as you can on the chat. Jan 2016, double award, international GCSE, January 2016, 2 hours, seems reasonable. Let me know if this is okay. Right. Use the periodic table on page 2. The symbol for silver is Ag, nice and easy. The element with the atomic number of 40. Oh, that's actually quite interesting. Argon, I believe, but I might be wrong. Because atomic number, yeah, neon argon's going to be argon. I don't know all my atomic numbers. I'm not really the best at my atomic numbers. Should be. Oh, I'm wrong. Atomic number, zirconium. There we go. There's me not knowing my atomic numbers. Zirconium. There we go. So you always check, by the way. The atom with the element with the electronic configuration 283 state the number of the group in the periodic table to which it belongs. The group, of course, is the final number, which is 3. Yeah. Explain your answer in terms of atom's electron configuration. Yeah. Explain your answer in terms of the atom's electronic configuration. Explain your answer. Why is it in group 3? Outermost electrons. Outermost electrons. There are 3 electrons in the outermost energy level. 3 electrons. 3 electrons in outermost energy level. Energy level. Hence group 3. They're asking for the term of group, so hence group 3. State the number of the period in which it belongs, which is 3 as well. Explain your answer in terms of electron configurations. There are 3 numbers. There are 3 numbers, 2, 8, 3. First shell holds 2, second shell holds 8. Third shell's got 3 in it. There are 3 numbers. So 3 energy levels. Seems very reasonable. So we just look at the mark scheme for these two. Identify the element. 2, 8, 3. Aluminium. It says identify, so we can use symbol or name. So I'm just going to put A out. Complete this for a fluorine atom. Okay, so X to represent your electrons. It's going to have 7 in it. Nice and easy. There we go. Next, question number 2. Bromine is an element in group 7. What is the name given to the elements in group 7? They are called the halogens. The symbol of 2 isotopes of bromine are these. Stated what is meant by the term isotope. Atoms with, notice the plural, by the way. Atoms with the same number of protons and electrons, but different number of neutrons. Now, in this case, they have given me an example, which means I need to use it. So I'm going to say, for example, bromine 3579 and Br 3581 both have 35 protons, and you're not allowed to write down P plus and E minus, so I'm just shortening it to make it quicker for me. Yeah. But Br 79 has, I don't know what that is, calculator. Never do anything without a calculator. It's a bad idea. I don't know what I've done with my, there it is, found it. So 79 minus 35 gives me 44, has 44 neutrons, but Br81 has, add 2, 46 neutrons. Newts, I like it. They've given us it in context, so we need to answer it in context, even though I've probably got the mark in the first 2 sentences. Oh, nice. That makes it easy. Number of protons for Br is 35. Electrons, of course, is 35. This one is 35. This one is 35. But then the difference is I've already done the maths. So 44 and 4. I am just going to check that bottom one on my calculator. 81 minus 35. Does it give me 46? Yes, it does. Jog on. Winner. Next, right. Distinguish between these two. Describe, you see, with orange, bromine, water is added separately to ethane and ethene in the absence of UV light. Cool. So with ethane, no change. Yeah, remains orange. With ethene, it will decolorize. Yeah, they want, by the way, edexcel want you to say the words decolorize. Yeah, they don't want you to say from orange to colorless. They'll accept it, of course. But they want you to say observation, bromine water will decolorize. Yeah, it'd be interesting to mark them. No change for the alkane. Right. Identify gas Z. The table shows the percentage composition of gases in the exhaust fumes of a car. Whoa, really high. Yeah, 71.5. So that's going to be nitrogen. It's only one gas that can be anywhere near that high. Yeah. Nitrogen oxides, carbon dioxides, carbon monoxides. Yeah. Oxygen's going to be low. Nitrogen. Carbon dioxide is produced from the combustion of hydrocarbons of octane. Complete the word equation. Nice and easy. Oxygen, carbon dioxide, and water. No need to balance because it's in words. How is the carbon monoxide fumes produced? Insufficient oxygen. Insufficient oxygen for complete combustion. Complete comb. Next. Write a chemical equation to show how nitrogen dioxide is produced in a car engine. N2 plus O2 goes to NO2, and don't forget to balance. Yeah, there we go. All adds up, 2 nitrogens, 4 oxygens, 4 oxygens. State 1 problem in the atmosphere, acid rain. Move on. State the name of the substance that turned anhydrous copper sulfate blue. It says name, so it's water. Watch out. If you write formula there, you'll lose it. Name the substance that reacts with lime water to turn it cloudy. Name again carbon dioxide. Lots of people will fall into that trap. There are loads of them. Explain why the copper turned black. It's reacting with oxygen. It's reacting with the excess oxygen. That's what it's doing. Well, it's reacting with the oxygen, period. Copper reacts with oxygen to form, sorry about the noise, guys, something, not all the noises. Copper reacts with oxygen to form copper oxide, and copper oxide is black. Copper oxide, which is black. They've got heat under there, but I think it'll be fine. I think that's probably going to get me 2 miles. Copper reacts with oxygen, 1 mark. Copper oxide is black. Seems reasonable. Next, plot the graph. Oh, the joys. Collecting gas in a gas syringe. Quite nice. So I've got to plot the graph. So at 0, 0, there is a plot there. Then there's sulfuric acid volume is 5. So it's 5, then 15, then 20, then 25. Isn't that interesting? They've done that deliberately. Then 30, then 35, and then 40. Isn't that interesting? They've deliberately done that. How fascinating. So that one's going to then be 16, which is there. Then at 15, it's 47. So that's there. At 20, it's 61, which is there. 25, it's 64. Slowing down now. 64. At 30, it's 78. Oh, that's weird. Big jump there. 78. At 35, it's 80, and it's 4. That's weird. Wow, I hit the top of it's not a good set of data, that. Do we have to draw a line of best fit? Draw a curve of best fit. Oh, that's going to be a nightmare, isn't it? And you've already got 1 shot at this. So I'm going to make that bigger, make the line fit my wrist. It's a real nightmare, actually. On a tablet, it's even harder. There we go. That'll do. That'll do. There's my anomaly. Next, which volume of sulfuric acid produced the anomaly? 25 centimeters cubed. Next, explain what the result with 35 and 40 is an indicator about the reaction. 35 and 40 tells us that the reaction, yeah, but we're at the maximum of the gas syringe. That's stupid, isn't it? Really stupid. Indicate about the reaction. It stopped. It's not just stopped. It's saying that so the volume of sulfuric acid added, it's going to be reacting with the magnesium carbonate. Right, let's write an equation for this because it helps. Magnesium carbonate plus sulfuric acid is going to create magnesium sulfate plus water and CO2. Right, they're telling us that if they're adding more and more sulfuric acid, yeah, starting with 5 and ending at 40, yeah, but what happens is when they have 30 and 40, they don't make any more gas, which means it's now in excess. That's what it actually means. So, about the reaction, it says that the sulfuric acid is in excess since adding more acid doesn't increase vol of CO2. You'd have to write volume, by the way, in your exam, but yeah, I think that's reasonable. Yeah, it's 2 marks. The sulfuric acid is in excess. Definitely 1 mark. It's going to be interesting to mark this. Yeah, since adding more acid doesn't increase the vol of CO2. It seems reasonable, drawn on the graph. Fine. Use the graph to find the volume of carbon dioxide that would be collected if 10 centimeters cubed was used. So at this point, you pull out your ruler. It does say you need to use the graph, so you need to actually draw on it. People often forget that. So I'm just going to, there we go. Oh, this is where there we go. So at 10, there we go. My volume, read that off there, is going to be 32 centimeters cubed. Use the graph to find the volume of sulfuric acid. That would result in 55 centimeters cubed of carbon dioxide gas. 55. Be interesting to know what range of these they get. Oh, look at that. It's right on the money there. So that's interesting, isn't it? If that's 15, that's going to be 17.5. That's what I get it as. 17.5 centimeters cubed. Let's move on. Write a chemical equation for the breakdown of mercury oxide into its elements. Mercury, HGO. HGO. So this is testing to see Hg plus, if you remember, O2. Balance the equation. Yeah, we're done, and that's going to be liquid. That's gas. I'm assuming the mercury oxide is going to be a solid. There you go. What is the name given to this type? This is a thermal decomposition. One thing going in, breaking into smaller ones. So this is a thermal decomposition. Nice and easy. Endothermic, requires heat. Give the name of the apparatus that contains the hydrogen peroxide. This is called a tap funnel. A tap funnel, just got to know those. Watch out for the thistle funnel as well. Suggest how the first sample of gas collected may be different from the samples collected because it will contain a small amount of air. May contain a small amount of air as impurity. Yeah, brackets, nitrogen, CO2, oxygen. Always nice to put all those in. Yeah, a catalyst increases the rate of decay. Describe a method you could use to show that the magnesium reactant is a catalyst for this reaction. Okay, that's nice. So step number 1, measure how much gas, and this is going to produce oxygen, so how much oxygen is produced by a fixed amount, let's actually give one, by how much oxygen is produced by 25 centimeters cubed of hydrogen peroxide in 30 minutes. No, let's go in 2 minutes. In 2 minutes. Yeah. Next, repeat the experiment. Repeat experiment. Repeat experiment 25 centimeters cubed. Got to show them that you understand the importance of the control variables. 25 centimeters cubed of hydrogen peroxide. Repeat experiment 25 centimeters and add 1, I don't know, spatula. No, let's add 1 gram of manganese dioxide, MnO2, manganese oxide. Measure vol of gas produced in 2 minutes. This proves that the rate increases. Then what we're going to do is we're then going to filter out MnO2 after reaction, dry it and reweigh it. If mass still 1 gram, then It's a catalyst. We need to make more gas and the catalyst not be used up. It's going to be fascinating to mark that. What a lovely question, if you like it. Sulfur burns in oxygen to write a chemical equation for the reaction when sulfur dioxide dissolves in water. SO2 plus H2O goes to sulfurous acid. Moving on. Universal indicators are added to the solution in D. Explain the effect on the solution has on the universal indicator. Universal indicator turns red. Universal indicator. It's annoying, actually, because it's a weak acid, so it should go orange. And at GCSE, I like to teach that. But in reality, it goes red. Universal indicator. Am I going to take a punt on that? Universal indicator will turn red or orange. Let's do both. Red or orange. Due to H2SO3 being an acid, and releasing H plus into water. Perfect. Definitely going to get us the mark there. Right, into rates. Love this. 3 rates. A is the fastest, B is the middle, C is the slowest. What did they do? Explain which curve shows the results obtained. So they did powdered 0.12 grams of powdered zinc, kept it the same. Excess hydrochloric acid. They have increased the temperature. Right, so the original line is going to be B, right? Curve B, yeah, the volume of the hydrogen gas in the experiment, the top one, this one here is B, yeah, which is the original. So this here is this one, yeah, and then this one here, this set of results, is at a higher temperature. So it's going to be A. And then they say explain which curve A shows the results obtained. Right, that's a horrible question. So explain which curve A. So it's going to be curve A, 1 mark for saying curve A. Yeah, and then I'm going to say it is steeper. It has a higher initial. It has a higher gradient. It actually has a high gradient all the way through. It has a higher gradient. So rate has increased. So rate has increased. And it also ended earlier. So it is steeper, but also it ended way earlier than that guy did, which would make sense. It has a higher gradient, so rate has increased, and reaction finishes earlier. I can even quote it, really. Yeah, so I can, oh no, I can't, don't need to. That's going to be interesting again to mark. Fascinating one. The experiment is repeated again using R. So this time as that stayed the same, They've now added 0.06 grams of powdered zinc. Which one is that going to be? So they've halved the amount of zinc, halved it, which makes sense for C to be the line. Which curve is it? So the first mark is for saying curve C. Yeah, explain that. That's interesting because the rate should actually be exactly the same and it's not. How fascinating. The rate should actually have been the same. The initial rate anyway, which is actually an incorrect graph, but whatever. Because the powdered zinc, then nothing else has changed. That's actually an incorrect graph. So it has half zinc added. So half, are they collecting hydrogen gas here? Yeah, volume of hydrogen. So half the vol of H2 collected. Yeah, and that's interesting because, I mean, it has changed the rate is slower. Really interesting. It's also, I mean, it's finished earlier. It's really weird. Like, there's that. Can I just point out, C is complete garbage. That's not the right line at all. My A-level kids will know that. Yeah, it's a complete mess. I'm going to say there's less zinc. So, but it's still powdered. Less zinc. So, rate slows. It's wrong. I don't know what the third mark is there because the line is incorrect. half zinc added, so half the vol of hydrogen collected. Because it's still powdered, assuming the powdering is the same, you are going to get half the product, but it will actually finish much quicker, but you're going to get the same rate as the other one. Okay, we can say finishes earlier since there was half the amount of zinc. Okay. Finishes earlier due to half amount of zinc. It's going to be interesting to mark. Next, chemical tests. So silver nitrate, sodium chloride, sodium iodide, labeled yada yada yada. Explain how the results show that Y is aqueous silver nitrate. Yeah. Oh, isn't that interesting? Solution X added to Y. So 3 aqueous solutions of sodium chloride, sodium iodide, and silver nitrate. They are in containers labeled X, Y, Z. It's not known which solution is in each container. The solutions are mixed together as shown in the table. Right. Isn't that interesting? They mix the two together. So that's clever. So the only one that has no change at all is X and Z going together. Well, that means that what you've mixed together is going to be sodium chloride and sodium iodide. That's clever, that, isn't it? Because you add those together, you get no reaction. They're just salts. Yeah, no reaction. So explain how the results show that Y is aqueous silver nitrate. When X and you can actually say when Y is added to both X and Z, you always form a precipitate. That'll work. Yeah, when Y is added to both X and Z, yeah, you always get a precipitate. And when you have no Y, you get no precipitate. Yeah, that's a nightmare. When Y is added to X and Z, PPTs, precipitates, are formed. When no Y present, no precipitate, no PPT. Yeah, Y must be silver nitrate. Explain how the results can identify both X and Z. Because if Y is silver nitrate and you then add Y to X, you get a yellow precipitate. Yellow precipitate, yellow PPT is silver iodide. So X is sodium iodide. And then white PPT is silver chloride. So Z is NaCl. Next. Aqueous chlorine is added to a separate solution of sodium chloride and sodium iodide. Explain how the observations made can be used to distinguish between sodium chloride and sodium iodide. So Cl2 added to NaCl, no change. No change. Since chlorine can't displace itself, chlorine can't displace. Won't displace, can't displace. It actually does. It goes into an equilibrium, but it doesn't really matter. Can't displace itself. And then Cl2 added to sodium iodide turns brown. Cl2 plus NaI goes to I2 plus NaCl. Balance the equation. Yeah, brown. Done. Oh, extraction of metals. It's gone now, meter. That's been deleted. The iron ore is mixed with 2 other raw materials and put into the top of the furnace. Give the name of the 2 other raw materials. So they put iron ore. The other one is limestone. The other one is limestone and coke, which is a purified form of coal, by the way. The most common use of hematite, which is iron 3 oxide, is converted into carbon monoxide. Write an equation. Right, so Fe2O3 plus CO goes to Fe plus CO2, and don't forget to balance. Yeah. If I go 2 there, oxygens don't add up. 4, and I'm going to have to do that, and then that. That doesn't add up either, because now I've got 5, and then I've only got 4. Oh, that's a nightmare. So if I put a 3 there, I put a 3 there and a 3 there, right, that makes sense now, because I've got 2 ions, 6 oxygens, 6 oxygens, 3 carbons, 3 carbons. I'm done. I like it. Next, explain which element is reduced. Which element is reduced? Iron is being reduced. Iron is being reduced. And just to tell you why, it is going from iron 3 plus to iron 0, iron metal. I'll actually put brackets from +3 to 0. There we go. So now we're doing, oh, this is interesting. Is this the Bessemer steel process? Wow, it is. I haven't seen that in a while. Yeah, 10% massive impurities. Yeah. Write an equation for the reaction in carbon and oxygen. That's nice. Form CO2. Done. The equation below. So this one's the removal of sand for this neutralization. I know. I'm sorry about that. Morning, Mr. Duncan. Hey, Nish. Good to see you. The reason why you know it's neutralized, you just have to know that sand is acidic. Even though it has a pH of 7 because it's insoluble, it's still acidic. And that, any metal oxide is a base. This is a neutralization. Yeah, just got to know that one. One problem with using iron is rusting. Name 2 substances that must be present for iron to rust. Water, name, by the way, don't give formulas. Water and oxygen. Lots of people will fall for the trap of writing in H2O and O2. One method of preventing rusting is to paint it. State how this method prevents it. Provides protective layer. Protective layer. Preventing water and oxygen from reaching iron. From reacting. I prefer from reaching iron. All words there. Iron can be used. Iron can also be protected by using zinc. Give the name of this type of protection. It's called sacrificial metals. Sacrificial metal. Explain how this method of protection works, even when the surface of the zinc is scratched and exposed to iron. So what will happen here is, this is a bit of a nightmare. So the first thing you need to state is that zinc is more reactive. Zinc is more reactive than iron, 1 mark, than iron. What that means is it will preferentially take the oxygen. Now, it's actually more complicated than that. What happens is if the rusting happens, yeah, so if this is a nightmare. This question's come up repeatedly, and I really hate it because they're wrong in terms of what they want on the mark scheme. Yeah, because what will happen is the iron will react with oxygen in the presence of the water to form iron oxide. Oops, to form iron 3 oxide. But then the iron 3 oxide will react with the zinc immediately, or Zn, the zinc immediately to form zinc oxide and iron, which reverts it back to the original iron. But this is just a bit of annoyance. They also have done this from a redox perspective. God, Zina will remember this question. Yeah, so what happens is the Fe3 plus will react with the zinc metal to form zinc 2 plus iron metal, and then you need to balance it for charge. 2 of those, 3 of those, 3 of those, 2 of those, and we're done. Nightmare. I'm just going to leave it like that. It's going to be interesting to mark that. Aluminium is extracted from its oxide using electrolysis. Why is aluminium not extracted by heating with carbon monoxide? Aluminium is above carbon in reactivity. Above carbon. Hi, Ian. Good to see you. Above carbon in reactivity. There we go. Why is iron not extracted from its oxide using electrolysis? Lol. It's just too expensive. It's an awfully expensive method for a very cheap metal. Because you don't have to. The only reason why we wouldn't, that's a really weird question. Too expensive. The iron that you would make, wouldn't be worth the money that it cost you to run the electrolysis process. Lol. Alkenes are unsaturated hydrocarbons. State what is meant by the term unsaturated. Contain carbon double bonds. This is going into organic now. Double bonds. One method to produce alkenes is the cracking of this. Write the equation. Cracking decane into octane, C8H18, and ethane, C2H4. Done. State two conditions used for cracking in industry. Zeolite catalyst, and 600 degrees Celsius. Done. The diagram below, the diagram shows two alkenes. Name why these two alkenes are isomers. The word isomer, same molecular formula. Same molecular formula. So now it says explain why these two, they've given us context, so we need to use the context. Same molecular formula, C4, there's 1, 2, 3, 4 there. C4H, now 1, 2, and then plus 6, 8. Yeah, same molecular formula, different structural formulas. Different structural formulae. Here we go. Draw a diagram to show the structure of an alkene that is another isomer of these two. Oh, isn't that fun? So you've got bute. That's interesting, that. So that we've got, if we're going to name these, this is bute-2-ene, because the double bond is between carbons 2 and 3. This is methyl-propene. So I'm going to draw bute-1-ene. That's clever, isn't it? I like that game. That's a fun game. Bute-1-ene. You don't need to draw it the way that they have. Just make sure you count your sticks, please, folks. So easy to add too many. Lots of people fall into that trap. Yeah, bute-1-ene. The structure of propene is this. Propene can be polymerized. Give the name of the polymer formed, polypropene. It's not hard, is it? You just stick the word poly in front of the alkene, the monomer. Draw the repeating unit for this polymer. So C bond, C line. Yeah, and then we've got a H. Then we put a CH3 up there, and then a H, then put that in a bracket and put an N on it. The repeating unit of the additional one for this glue is this. Draw the structure of the monomer. Just put the double bond back. C, double bond C, and then just put everyone else back on. That is it. How easy is that? COOCH3. Don't even bother to change anything. You're done. I love those questions. Next. Oh, cobalt chromate. Wow, I was talking about this in my A-level chemical tests one. I didn't use cobalt, though, as the example. Cobalt's pink, by the way. Yeah, cobalt pink. It says the apparatus shown in the diagram is the colors of the cobalt 2 plus and the chromate. Yeah, that's really interesting because the results. I'll show you, explain why the results show that chromate ion is yellow. Right. So the pink color has moved towards electrode A, and the yellow color has moved towards electrode B. Now we know that the chromate ion is 2-. Chromate ion is yellow, so you put chromate. I'll do the words. Chromate chromate is a negative ion. Negative ion, so will be attracted to the positive electrode. Positive electrode. And I'm going to say electrode via electrostatic attraction. Via elec-stat. Attract. Done. Opposite charges attract each other. Right, the chromate ion in the aqueous solution can be converted into dichromate by the following equation. Balance it. 1 Cr, 2 Crs. Okay, 8 oxygens. Oh, that works out well. 8 oxygens. Nice. Hydrogens. 2 on this side, 2 on that side, and I'm done. Thank you very much. It's nice and easy, isn't it? Which solution is the source of hydrogen ions in the reaction? The only acid there, which is B. H plus is what makes an acid an acid, so find the acid in the equation. Next, or the acid in the question even. When aqueous potassium chromate is added to lead nitrate, a yellow precipitate forms. Cool. Add state symbols. So aqueous, look, an aqueous potassium chromate, so that's AQ. Aqueous lead nitrate, is AQ. Bright yellow precipitate, which is going to be him, aqueous. And then potassium. No, sorry, yellow precipitate, which is a solid. We're done. Describe how you could obtain a pure dry sample of the insoluble solvent in the final reaction. So filter out solid PbCrO4, wash with distilled water, and then leave to dry in a warm place. Leave to dry in warm place. Yeah, drying oven if you like. There you go. Moving on. Question 12. How long has the webinar been going on so far? Let's just check how we're getting on. 45 minutes. Don't know how much longer I've got to go on. Question 12. It is a very long paper. Question 12 of 15. Okay, it's not going too badly. Okay, calculate the amount of moles of sodium carbonate in the reaction. So a solid lump of sodium carbonate. So there we go. And it's even giving you the MR. That's nice. Number of moles is grams over rams. So grams is 0.53 divided by 106. Don't even need the periodic table. I hate edexcel for that. Why bother? Why bother? 106. Gives me 5 times 10 to the minus 3. You can write that down, by the way, in your exam. It's totally fine. Yeah, I'm going to go Shift-N on my calculator. 0.005. Yeah, the volume of carbon dioxide collected is 110. Use this in the calculate the volume in centimeters cubed of 1 mole of carbon dioxide. Oh, that's interesting. How fascinating. So that's quite clever because the ratio here, because we now know the moles of this guy. Yeah. And we've got a 2-to-1 ratio, which I need to write down. Yeah, so 2-to-1 ratio. So the 0.005 will be divided by 2. So divide that by 2. And that gives me 2.5 times 10 to the minus 3 moles of CO2. Well, hang on a minute. They've just told us that we collected 110 centimeters cubed of it. So what would be the volume of 1 mole of this? Well, if we now just do the volume in centimeters cubed, 110 divided by 2.5 times 10 to the minus 3, 110 divided by answer, and I get 44. Oh, that's interesting, isn't it? It's given me twice my number of 1 mole. Isn't that fascinating? But that's how much we... yeah, that seems okay to me, and then I've got the wrong answer. 24,000 should be 1 mole, and I've got 44,000. How fascinating. I've got a larger volume than I should. The volume of carbon dioxide is collected. So I had that. I did halve it to get the moles of CO2, which is correct. That's the moles of CO2. The volume collected was that. If I divide that by that tiny number of moles, I'll end up with what I get at 1 mole. I don't like that at all. I don't like my answer. That's the first time I want to see the mark scheme immediately. That's weird. It shouldn't be. It should be 24,000. Why have I got a larger number than I should? First time I'm questioning myself in this paper. How fascinating. What have I done wrong? All seems reasonable. That's odd. Okay, first thing I'm going to make a mistake on, it's a calculation. I never make mistakes on calculation. I hate that. That does not make sense. Calculate the moles of sodium carbonate that reacted. The lump of sodium carbonate is placed in an excess of nitric acid. So, let's check my maths. 0.53 divided by 106 grams over rams gives me 5 times 10 to the minus 3. Right. Divide that by 2 to get moles of carbon dioxide that I should get from that reaction. That equation is balanced correctly, divided by 2. 2.5 times 10 to the minus 3. The volume of carbon collected was 110 centimeters cubed. 110 divided by answer. And I get 44,000. That's really weird. The correct volume of the correct value of the volume of 1 mole under standard conditions is 224,000. Suggests 2 reasons why the volume calculated is less than the correct value. Oh dear. I've got larger than the correct value. How have I gone and done this? Moles of CO2. Right, so this... Can you explain 11A one more time? 11A. 11A. Oh, yeah. Yes, I can, Meter. So the trick to this question, Meter, was it's in the question. They tell you that the cobalt is +2. Yeah, sorry, I'll do them in the correct colors that go with, I'll just circle them. Cobalt is +2, and the chromate is -2, and then they gave you the colors. Yeah, and it then says, explain how you know that chromate is yellow. And they've said yellow moves towards electrode B, and electrode B is the positive one, which is going to attract the negative ion, which is that one. Yeah. Whereas this one, it's the cobalt 2+ is going to be attracted to the negative electrode, and that goes over to that one. Hope that helps. Yeah, I've done something really odd here. Maybe it should be 22. Should I be dividing it by 2? But that's the thing, like, oh, hang on a sec. Yeah, it should be half the number. It should be 22,000. The volume of carbon dioxide collected is this. So I've done a trick here. The moles of CO2 produced should be half the number. Why would it not be? Because, yeah, if you do 110 divided by 0.005, you get 22,000. But why would you get that? It would produce half the amount of CO2. Weird. It's very strange. I feel like I'm not doing something right there. Use the information and your answer to calculate the volume in centimeters of 1 mole of carbon dioxide. It doesn't make sense. It's a 2-to-1 ratio. You should make half the number of moles of CO2. I don't like that at all. Use your answer to part A. All right, 0.005. Sorry, 110 divided by 0.005. I feel like that's not okay. 0.005, and you get 22,000. Use your answer to part B. It's weird. Suggest why your answer is smaller. So we're collecting gases underwater. So some of the carbon dioxide is going to be dissolve in the water. They're also going to lose a small amount of gas before the bung is put on, and those are your 2 reasons. Some CO2 dissolve in water, and some CO2 escapes before bung is sealed. Before bung is sealed. 2 marks. Move on. Name a metal from the list that is extracted by electrolysis. Magnesium, sodium, potassium. Let's go for the top one. Of course it is. Lol. Potassium. It's just the highest. You need to be above carbon. That's all. Just be above carbon. And recognize that carbon goes there, by the way. Carbon goes in between magnesium and zinc. Uranium is a metal that is between magnesium and zinc in reactivity. Equal sized pieces of 3 moles placed in solutions of dilute hydrochloric acid. The observations were made. Complete the table. So it's saying that uranium metal goes between magnesium and zinc, just like carbon does. So uranium goes here. I believe. Yeah. So it then says with magnesium, bubbles of gas produced very rapidly, solid disappears very quickly. Zinc, bubbles of gas produced slowly, solid disappears slowly. So complete the table for the observation. So bubbles, bubbles of, look, we've got very rapidly and then slowly. So bubbles of gas rapidly, it's not saying very, just rapidly. Solid disappears quickly. I'm ignoring the very, that's what I'm doing. Disappears quickly. Isn't that really stupid? Metals high in the reactivity series react readily with water. Name a compound form that potassium reacts with water. Oops, gotta be careful. Potassium hydroxide, KOH. Give the formula. Oh, name, and there you go. I did it, didn't I? I did it. Potassium hydroxide. Gotta watch out for that. You know, it's so easy. Potassium hydroxide. Give the formula of the compound form with magnesium reacts with steam. Give the formula. That's weird. You get magnesium oxide. You don't get magnesium hydroxide because it's with steam. Zinc can be extracted by heating zinc oxide. Explain why zinc or carbon is more reactive. Carbon is more reactive. 1 mark. Carbon is more reactive, but it says explain. More reactive since carbon displaces zinc. We're done. Next, explain which element is acting as a reducing agent. That's going to be carbon. Carbon is the red agent because it is removing oxygen, moving oxygen from zinc oxide. I'll do. Next, right, plunger gas equilibriums. Yay! The plunger is pulled out to reduce the pressure when the equilibrium mixture is darker in color. Explain this observation. So this is equilibrium. We're going to run COFs. COFs, yeah, we don't even need to do COFSy. Yeah, it's just COFs. So knowledge, yeah, knowledge. This is a gas one, and this is pressure. So there's 2 moles. Oh, oh no, I've had this happen before. I don't know why it did it, but there was definitely, this has done this before to me where my laptop decides to go haywire. Oh, stop it. Is it because it's probably overheating? My little fan's drifted away again. Oh, no. Oh, darn it. Guys, this might be a problem. 2 moles. 2 moles of... 2 moles of gas on left and 1 on right. Sorry, guys, my pen's busted. I don't know why it does this it's my laptop has an issue with this every now and again. I don't know what's causing it. Really sorry. Oppose. We reduced pressure. We reduced pressure. Equilibrium. Equilibrium will increase. Will increase the pressure. Sorry, guys, there's nothing I can do about this. Yeah, otherwise I have to restart my laptop, and I'm not going to do that at this point. COFs favors will increase the pressure by favoring side with less gas. I'm stuffed to this, guys. I'm sorry. Meter, I think we're just going to have to end it here now. Favoring the side with less gas, shifting it from left to right, more NO2 produced turns brown. We're so close to the end of the paper as well. The sealed tube containing an equilibrium mixture at room temperature is plunged into water at 0. The color of the mixture changes from brown to pale yellow. Explain whether the reaction is exothermic or endothermic in the forward direction. Right, so they've lowered the temperature, room temperature to 0. So the knowledge, so favors, which it went pale yellow. So it favored the right. Yeah, so it favored this side, which means the equilibrium went that way. And we reduced the temperature, so it's trying to increase it. Forward reaction is exothermic. Yeah. I would explain that by saying coughs in reverse. Equilibrium has shifted left to right towards NO2, which is colorless. So it's shifted left to right. Oppose. Favor. It did this by favoring the exothermic reaction because we lowered the temperature. We're done. Next, if the forward reaction, a bond is formed between the nitrogen. Okay. Explain whether this information supports the answer in your question. Mexobendo. Yes. So making bonds is exothermic, and that is exactly what's happening. We're making a bond between the two. It does indeed. So 1 mark for saying it supports, and saying why, because making bonds is exothermic, mexobendo. This is the last question on the paper. Write the chemical equation, reaction between magnesium and nitrogen. That's a weird thing. Magnesium and nitrogen going to form magnesium nitride. Magnesium is +2. Nitrogen, of course, is 3-, crossing down. There we go. Balance the equation. 3. I'm done. The equation for the reaction between lithium nitride and water is this. Describe a chemical to show the gas is given off as ammonia. Right. So the test for ammonia gas. So we're going to use damp red litmus paper and it will turn blue. Alternatively, you could use concrete hydrochloric acid and it will form white smoke. Hey, Nick. So 2 tests there you can use, but damp red litmus paper turns blue. Perfect. A sample of 1.4 is added to excess water. Calculate number of moles is grams over rams. It seems to me like my laptop seems to be actually going back to normal. And I think it might be because it's overheated. So grams, 1.4 grams over. Now they haven't given us its MR. Now they're making us work for this. So lithium is 7 on the periodic table. Nitrogen is 14 on the periodic table. So I've got 7 times 3, so times that by 3, times that by 1 and add them together on 7 times 3 plus 14. So it weighs 35. 14 over 35. Sorry, 1.4 over 35. And I get 0.04 moles. Calculate the moles of lithium hydroxide formed. Right. So the ratio is a 1 to 3. So I'm going to multiply it by 3. Ratio is 1 to 3. So I'm going to multiply 0.04 by 3 times by 3. And I get 0.12. Done. Calculate the volume of sulfuric acid required to neutralize the exact amount of lithium hydroxide calculated in B. So we've got 0.12 moles of him. The ratio is a 2 to 1. So divide it by 2. So divide that by 2 and I get 0.06. Now they've given us the concentration. They want the volume. Yeah. So number of moles is C times V over 1,000. Right. They've given us concentration. Yeah, they've given us concentration. They want the volume, and I've got moles. Reorganize. Bring the 1,000 over. 1,000 times moles. Yeah, look, it's starting to settle down again. Divided by concentration will give me V. Now I've said that, and I was doing it again. So 1,000 multiplied by my answer of 0.06, divide that by the concentration of 0.5, and I get a volume of 120 centimeters cubed, because I have 1,000 in there. And that brings me to the end of the paper. Now, it'll be useful for me to see the mark scheme on this. Definitely questions I want to check, for sure. Let's have a look. Mark scheme. So what I'll now do is, I don't know how to make this stupid column disappear. Oh, yeah, I do, don't I? So I'm going to split that there. Put this onto that one. Put this one onto the other side. See if I can make everything fit. There we go. This is going to be entertaining. So, oh, have I got a different paper here? Be so careful getting the right papers and masking if they say it is. Brackets HE. What? What? There's something weird. That mark scheme is not the right one. Because it's not the right one. Oh, Jan 17. I want Jan 16. Right, there we go. So, let's go for red. Silver. I'm going to shrink that. Get D. 3. The atom has 3 electrons in its outer sloped valence shell. 3 electrons in outermost energy level. Get 3. 3 has 3 shells. 3 shells are occupied with electrons. There are 3 numbers, so 3 energy levels. Yeah, it says the atom has electrons in 3 energy. Yeah, okay. Aluminium. Fluorine. Doesn't matter where the dot goes. Halogen. Atoms of the same element. Atoms of the same, with different masses, except atoms with the same atomic numbers, with the same number of protons, except different mass. Ignore reference to electrons unless incorrect. Different masses. Different numbers of neutrons, that's correct. Same number of protons and electrons, different number of neutrons. Next, 35, 35, 46, 44, done. 3 marks there, thank you very much. This is going to be an interesting one. First column, yeah, there, no change. Decolorizes, there you go, orange to colors, actually preferred in that case, weird. Next one, nitrogen. Identify the gas, water and oxygen. Insufficient, incomplete combustion, except burns in a limited supply, shortest. Rejections, I'm going to put insufficient, it's definitely okay. Balanced equation, produces acid rain. Water, carbon dioxide, copper reacts with oxygen to oxidize, and copper oxide is black. I like it. There's my graph, tick, 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 3 marks. Is nice. All plots correctly done. 25 centimeters cubed. Sulfuric acid. The next one, explain why the results indicate the volume of gases are the same. Ooh. So adding more doesn't increase the volume. Oh yeah, it doesn't increase the volume of gas. Therefore, the reaction has finished. All the solid magnesium carbon is reacted. Yada yada yada. Oh, that's interesting. That's garbage. I'm gonna lose one. Should be the fact that it's in excess. Okay, it's all been used up. I'm going to lose that one, the excess part. So what they wanted there was for me to say all magnesium carbonate used up. Yeah, mental note. This is going to be the value correctly on the neatest line of the grid. Okay, so they actually don't give a range so much as read off their graph. Hydrogen, mercury, good. Oh, redox. Ooh, except thermal decomposition. Take it. Tap funnel. May contain small amounts of air. Contains air. So, perform reaction without catalyst. Yay, 1 mark. Yeah. Keep remaining variables, concentration, volume of hydrogen, and all the same. Measure the time to fill the gas jar. Produce as quickly as... Oh, okay. Lots of different methods here. Or weigh the sample of magnesium, filter out, dry, solid mass should be the same. I'm definitely going to get at least 3 of those guys. It's funny, actually, because they're saying that, you see, repeat experiment, hydrogen, add 1 gram of measure the volume of gas produced in 2 minutes. Filter out, I would get all 4 marks for that because it's a very reasonable method. H2O and water, sulfurous acid. Universal indicator will be orange or yellow, except red. Winner. I told you it was a punt. Solution containing hydrogen ions. This is the garbage question. That was rubbish. Got an incorrect graph line. Curve A, the faster reaction at a higher temperature. Yeah, therefore curve is steeper. Oh, higher gradient, so rate increased. Yeah. Levels off sooner. Look at that. I like it. I'm going to change that. Levels off sooner. Levels off sooner. Yeah. Curve C, half the amount of zinc used, so half the volume. Half zinc added, so half the volume of H2 collected. Nice, didn't even need to do the other one, which is why I was stupid. A precipitate was formed that took place each time Y was used, or no precipitate was used when it was done. There you go. Yellow precipitate, iodide, Z, sodium chloride, yellow precipitate gives white precipitate. Yeah, all that jazz. X is iodide. C, no reaction with sodium chloride, changes color to a brown solution with iodide. Yeah. Coke, limestone, balanced equation, all formulas and balancing. Right, iron has lost oxygen. Iron is being reduced. Yeah. Except gains electrons. Iron has lost oxygen. Iron is being reduced. I'm giving oxidation charges. Yeah, so that's just, oh look, oxidation numbers to 0. Perfect. Yeah. Nice carbon oxide neutralization. Oxygen and water. Galvanizing. Ooh, ignore sacrificial protection. Oh no. It's by coating. Coating with zinc. Galvanizing. First one I've really lost a mark there, guys. Mental note. Zinc is more reactive, therefore corrodes preferentially in preference too, except reacts with water in preference, references zinc converted iron 2+ to iron atoms. Well, I did iron 3+. Don't see why that would be a problem, but okay. I actually said the right words. I'll say that. Zinc preferential. Preference. Can't write, my tablet's broken. Preference aluminium. Cost. There you go. Too expensive. Contains a carbon. 600, 700. Perfect. Zeolite catalyst. Accept zeolite. There you go. Formulas are good. Repeating unit is good. Yeah. Double bonds gone back in. Chromates are negative. Chromate is negative, so it'll be attracted towards the positive electrode. Like it. Balanced equation. HCl. Aqueous solid. Filter, wash, dry, and warm oven. Calculations. This is the one which really annoyed me. 5 times 10 to the minus 3. Answer, volume of CO2. That actually is incorrect, by the way. It's actually an incorrect calculation. It's not okay. The moles of nitric acid. Sorry. Oh, just made a mistake. I've just spotted my mistake. It was sodium carbonate. That's a 1-to-1. Aha! Found it at last. RTFQ. Read the question. Some dissolves in the water. Bung was not placed on quickly enough. Carbon dioxide dissolves. Impurity. I'm glad I found out where my mistake was there. Potassium. Bubbles rapidly or quickly. Solid disappears quickly. Sodium hydroxide. Magnesium hydroxide. More reactive. Displaces it. Moves oxygen. I like it. Coughs. Darker. More NO2 is formed. Equilibrium shifts left because there are more moles. It's all good. White smoke formed. Yeah, I'm happy with all this. 120. There we go for M3. Cool. And that's the end of the paper. Right. I'm sorry that my tablet failed towards the end, guys. I do apologize. Let's bring this all back to here. Stop share. Right, guys. I will leave you guys be. I hope you found it useful, Meter. Sorry, my network's down. No problem, Meter. I hope you found it useful. I will see you for the next one. See you later.